All right. So Max Schlotter, I'm Health Innovation Lead at Clarity Insights, and I'm here with Omar Shaker, our Clinical Data Lead. Just wanted to thank...
Go ahead.
Okay. Thank HL7 for the conference and for obviously everything that we've been talking about the last couple of days related to FHIR. It's been a great learning experience for us just to see all the energy that's here in this room and throughout all the sessions that we've had the last day and a half. 15 minutes, I was told I couldn't talk for 14 minutes and give Omar one for the demo, so I'm going to try to get through this as fast as possible. I'm going to go here. So I'll talk a little bit about Clarity, go into some of what we do around innovation, and then hand it over to Omar to talk through our FHIR adapter. So Clarity, we unleash your insights, great tagline. Thank you, marketing. What we do is work with data analytics through engineering, strategy, science, and visualization to create solutions that work for our clients. We're 100% focused on data analytics and US-based. We have 400 consultants spread across 4 different offices within the country. Again, our goal is really around business value and coming up with solutions that can take you to there the quickest. The biggest thing for us is around enablement. What we want to do is come in, solve a problem, and then enable our organization to be able to take that over as we leave and get out as quickly as possible, while keeping our clients whole, of course. A little bit about our healthcare practice. So we are across 5 different industries, so it's not just healthcare. Within our healthcare practice, this is our largest growing, fastest growing industry. You can see our capabilities really along the data value chain from strategy all the way to advanced analytics. We work across the healthcare ecosystem, and really our vision and mission is around disrupting the healthcare market. We know Triple Aim, we've heard a lot about genetic testing and the data that's there and big data, everything that's coming our way. We're looking to utilize that information, be able to empower our customers to build out better solutions. We do this through an innovation framework, essentially an R&D framework from idea generation through idea testing. What fails, let's go back and start over. What succeeds, let's move to production. And it looks like we have some fun formatting as we translate it over from our system here. But what we do is typically, all of our work is centered around this framework. We customize it for our clients. Usually the first couple of weeks that we come in is we look at how you approach different problems and then make this fit to your needs. So I'll go through our data ingestion framework. It's a general framework, and it's what our FHIR adapter is based upon. This is one of our graduates from our innovation framework. So what this is really, it's built in Hadoop technology. So this is use of Spark, Hive, Scala, all the terms that I'm 50% aware of, but am able to come up here and talk about and be dangerous with. The idea is essentially to take any data source, translate it into any target then. So whether it's FHIR, whether it's XML, JSON, whether text files. I see a lot of squinty eyes trying to see this. I think we'll get the materials out to you all as part of the presentation. Move on. Everything that is driven around this framework, it's metadata based. So based on the structure of the source and the structure of the target, we build automated transformations from source to target. What we have for this framework is a set of connectors, ingestion components, and common services that are already developed. And then we have external integration services that allow us to capture that metadata, store it in a solution that's then available for end users to be able to consume. This is all very raw at this point. We do not have data visualization on top of that. You'll see what Omar's going to show here in a minute in terms of those capabilities. But this is it's a framework, it's a foundation. The intent is for it to grow and expand as some of these open source technologies do the same. And then there's an architecture, another eye test for everyone, but this is essentially translating what we've talked about from the concept into architectural components that take data from the source into information delivery. This is our foundation for FHIR, and you'll see this architecture slide again with a little bit more nuance with respect to our FHIR adapter. And I didn't take 14 minutes, I don't think, so I'm going to hand it over to Omar.
Thanks, Max. Since we have this nifty mic, I think I can move up here. That doesn't bother you guys, since we're here all here to break boundaries, and this seems like a pretty big boundary to me. I'm Omar. I've joined Clarity 2.5 years ago. I come from a medical background. I studied and practiced medicine, and then did this dramatic shift into data analytics. The first client that I was on was one of our big payer clients, and they hired us for about $1.5 million to help them make sense of lab results file for the risk adjustment. And the problem was that a lot of those lab results were not standardized, and even worse, there were no loin codes. So I had to use a lot of my medical knowledge to actually group those lab results together and say, okay, all those 4 things are this one thing. And then we were looking for a good structure to actually save the output metadata in, and that's when I learned about FHIR. Soon I started advocating for it within Clarity and with our clients, and then before you know it, I became a FHIR quote-unquote expert. And a year later, the same pair was hiring us to ingest CCDs. So my first impression was, why are we not getting it in FHIR? And their response was that the Health Information Exchange doesn't have very mature FHIR resources yet, and so let's get it in CCDs and then see what happens a year from now if they do have better FHIR resources. So we weren't satisfied. We saw pretty much the same problems with medical devices and providers, and so I went back to the clinical innovation or the innovation framework that Max was talking about, and figured out a way with them to actually customize that for clinical data ingestion. And so basically all the Python code that we wrote to clean the data and store it in a FHIR output, and also to flatten out the CCDs, though any Python code can be run in our innovation framework. The way it works, you can ingest the file no matter what the format is. It can be an XML or a JSON or a text file. The framework creates an input metadata, and it stores it in an input Hive table, and that's really important and huge here because the business users can then run queries straight on whatever file you're ingesting, and then it runs through the Python or whatever code that we have in there, and it creates an output metadata, and in our case, it created a FHIR output notation. What's really powerful about our ingestion framework is then all our output tables are then stored in a data lake where you can create some cross-sectional analysis and come up with some pretty cool insights about the whole organization. So looking at those lab results against things like billing and claims. And so what I'm about to demo is essentially this. So we recreated whatever I put together through just understanding of these clinical elements. So we had, on the left, a lot of lab results, non-standardized. Entity resolution is a machine learning algorithm which we use to cluster these lab results into bigger groups, as I'll show you. And then more importantly, we store the output metadata in a FHIR format. So those are FHIR resources that then we can use to deliver value to our end users. And so this is a quick example. The non-standardized columns, such as lab_val, are changed into the observation notation. So observation.value, observation.interpretation, and so on. And so the FHIR output is stored in a way that our client can use it again over and over. This is kind of the bigger picture. The data can come in from anywhere. There's a lot of sources in healthcare. So that can be a health information exchange. That can be a provider or a pharmacy. It goes in through the ingestion framework. There's an operational Hadoop store, which essentially allows any user, again, to say, bring me that patient's record. And then it moves into the clinical data warehouse, where you can then start doing analytics such as, how many diabetics do I have? What is my aggregate hemoglobin A1C? More population health like analytics. And then because we have everything in the platform, such as Hadoop and Spark, all the tools that allow you to actually create predictive analytics with, and visualization tools, as I'll show you, to help, again, drive value to those end users. And that can be a patient, a provider, or another partner organization. And so this is kind of our vision for our healthcare clients in 2020. They can be receiving files. It's not a one-off solution. They're not receiving files from one source, and they're not ingesting it in one way, but they are more at the center of the ecosystem, bringing in data from multiple sources, and then driving value again through the patients. So that can affect, help them with care management, disease management, risk adjustment, or even customer satisfaction. So this is the bigger vision, but slides apart. We'll play a little video showing how this ingestion framework works. So we start off by the text file so this is a dummy file again. So as you can see, there's glucose POC, glucose test, and these are all like the same thing, glucometer test. So as soon as we ingest it in the framework, the Hive table is created, and then business users can start querying the data, and it stores it in a nice kind of table, which is a Hive table, and that's, you can't even compare that to its ugly sister over here. And so we have a table that is broken down in columns. You can write queries on, and then over here, this is basically how we initialize the process. So we start by running our Python code, and it creates a weird sound. Is there a way to just audio? There we go. And so this is kind of like there we go. So this is the flow of the ingestion framework. So all these are different components, and the idea is that you can recreate that, you can rerun it with different pieces of the code without creating a new framework every single time. And so we essentially run the FHIR adapter. It does two things. It groups the lab results and also creates the FHIR.notation in the metadata. And so on the left here, you can see the data lake. So there's both input and output files now. And then this is the output Hive table. Again, so I'd just like to draw your attention to this column over here. Everything that was a glucose or glucose test or glucometer test became random blood glucose. And so that makes analytics really easy. Also, as you can notice, all the FHIR notation is used for the observation resource. The other part, which was a lot of fun, we did that a year later. A lot of you, I'm sure, are familiar with XML and CCD. It's not something that is trivial for a business user to read. It's not very user-friendly. So another thing our ingestion framework does is that it captures that and then flattens it out in an output Hive table again that is also queryable by users. They can write SQL in the same way they're used to. And as you can see here, it's flattened out. There's no more XML. The last part I want to show you, and that's one of the biggest values that we were able to drive for our clients, is that we also created profiling tools that help you immediately assess the data quality of the CCDs that you are receiving as a payer or a provider from a health information exchange or from other organizations. Data is not cheap, so you want to know what's in there. And this is the result of the profiling. So you can see each component in the CCD, and you can figure out quick, things like how many observations do I have, how many values, how many authors and providers, and so on and so forth. And then because this is built on Talend and Tableau, you can integrate it with any visualization tool essentially. So right here we're connecting to our Hive tables. So all the output tables that I showed you can be easily visualized, and you can drive a lot of value from it. So you can see these are the columns from the output table. We can run some quick analysis to see how many results we have using all this output. This is us using it in D3. Looks way cooler. These are the results of the profiling. So we've broken down all the components in a CCD, and essentially because of that flattening out of the ingestion framework, you can see how complete each component is. And based on that, we actually, we can drive decisions. So we decided based on this specific profiling to go with lab results because it was the most complete resource or the most complete component. One last thing I want to show you is also an analysis that we did for code. So again, because we have this flattened out structure, we can visualize things like how many ICD codes are in the CCD, how many LOIN codes, how many CPT codes, and so on and so forth. So this gives us a lot of insight, whereas ingestion of data can be in the dark. Thank you.